Hello, my name is Andriy Lutskiv and my course name is Lutsyshyn, and our thesis, Corpus-Based Translation Automation of Adaptable Corpus translation module, devoted to development of translation module for Adaptable Corpus tool and which allows to automate translations. Available Corpus tool is presented in our previous works. To achieve the main objective of our research, the following tasks should be resolved. At first, a machine translation method should be chosen and justified. It is evident that nowadays the most efficient way to implement machine translation is neural machine translation method, but this method also should be justified and compared with other methods. Neural network model, especially architecture of neural network model, should be chosen and justified. Based on justified architecture, neural network model should be implemented as a computer system which comprises software and hardware parts. To train developed neural network model should be prepared training data set. By using this training data set, developed neural network model should be trained. And finally, the quality of trained model should be assessed. Developed translation module should be able to convey the meaning of the text, translate from ancient languages, translate old dialects and local dialects, take into account stylistics of the translated text. The main translation quality criteria are: adequacy is a criterion which depicts if all the meaning was expressed from the source to the target language. Fidelity is a criterion which reflects the accuracy of the source text, meanings translation. And fluency is a criterion which shows grammatical correctness and how easy to interpret them. The whole corpus data platform is depicted in this figure, and a translation module which developed in this work is depicted in this place. In this research, we have focused on development of back-end part, and front-end part will be not covered in this research and investigation. At first, existing corpora tool, which is described in our work, allows to ingest text data and preprocess it by making tokenization, post and syntactically tagging. Build frequency dictionaries, find and extract collocations with frequencies, find semantically close words and texts, find the most important concepts and related terms and documents, find importance of the terms for different documents. Also provide ability to work with parallel texts in different languages. English-Ukrainian pair, Russian-Ukrainian pair, English-Russian pair, and also French, German, and Italian texts are ingested, but text pairs are not prepared. Nowadays, only these three pairs are available, and we worked with them. Now tool is oriented on translation of historical and religious texts. That's why training data sets will be also chosen according to these criteria. Also important to notice that this tool resolving topical modeling task by using latent semantic analysis. This machine learning technique depicted in our previous works. A training data set should conform to the following requirements, and the first requirement is that a developed corpora is oriented on translation of historical and religious texts. It should be rather large, and English and Ukrainian Bibles were chosen, especially its Christian Standard Bible and новітній переклад Олександра Гижі, 28,474 pairs of Ukrainian equivalents in English text fragments were extracted and prepared. Size of each pair is in the range between 20 to 30, up to 60 sometimes, words. It could be 1, 2, or 3 logically and semantically connected sentences. And what about text processing in developed translation module? At first, it's sentence extraction and term tokenization. When we are talking about sentence extraction, that means that we put text start of the sentence and end of the sentence at the beginning and at the end of each sentence. The next is byte pair encoding, which allows to prevent rare word problem. The next is converting tokens to semantic vectors or embeddings. For this purpose, word-to-vec approach was used. And also use this model to translate input text sequence in source language to text sequence in target language. So for this, neural translation method approach was used. Advantages of a transformer sequence to sequence neural machine translation model. At first, this transformer model was chosen for our translation module because it takes into account language sequential structure. It takes into account different word order and in source and target texts. It takes into account different number of words which represent some idea in the source and target languages. Could be parallelized in opposite to recurrent neural networks. What are the main transformer peculiarities? At first, it has two stacks, encoders and decoders. Encoders encode text from the source language and decoders decode text to the target language. There are 6 encoders and 6 decoders in our implementation. Using multi-head attention mechanism, which allows us to increase accuracy of translation and allows to parallelize our tasks. In our research, use transformer, as mentioned before. Now it is state-of-the-art neural translation processing approach, and The main work which me and Mike Orsov followed in our research is the work Attention is All You Need, which was published in 2017. Neural network model training has few criteria. And what are the main criteria which allows us to say that this model is trained? At first, it's a loss function criterion. We use cross entropy of the probability distributions of the trained model output and the predicted value. The next criterion is learning rate criterion. We use adaptive learning rates, such as average, stochastic gradient descent method, and its implementation in a PyTorch. Perplexity criterion, a language model intrinsic evaluation metric of how well a probability distribution predicts a sample. And one of the most important criterion is translation quality. Between considered metrics, the most suitable are BLEU, Meteor, and Rouge. Due to language independency, wide adoption, and low calculation complexity, the BLEU metric was chosen. This metric is widely used because it highly correlates with human assessment, and it has several variants, also support multiple references. A references is a translation by a human. So in our investigation, we are using two terms. First is machine translation. It is the output of the algorithm or a model, and reference translation, it's a human translation. The value of BLEU metric is between 0 to 100, and scores over 30 generally indicate understandable translations. Scores over 50 usually indicate fluent and good translations. Training process should be stopped or finished after few indicators. In our research, we follow the next rule. If during 4 or 5 epochs the value of the loss function and perplexity are the same or change no more than by 0.01, the value of adaptive learning rate also is too small, and the value of the BLEU metric is not changing, we will finish training of our model. We have to take into account and avoid underfitting or overfitting of our model. In our work, we also present results of overfitted model. It is shown in a figure in our work. In the follow slide, we see the example of execution. It's Python implementation with the firesec and transformer model. We are translating from Ukrainian into English. We're using this translation. And what about assessment, final assessment of translation at all? We made assumption. Text from machine translation and text from translated test sample dataset should be very semantically close. And sometimes this text should be identical. The following approach was used. Text data were converted to vector space, text embeddings, and similarity between these two vectors was calculated. The value in the range from 0 to 1 shows semantic similarity between machine translation and reference translation. 0 means semantically not close, and 1 means identical strings. In the follow figure depicted the results of this evaluation, and we see that two strings which are very close semantically have high result which is very close to 1. We can say that these two texts are semantically close. Thus, transformer sequence-to-sequence neural network model for neural machine translation was chosen. Based on heuristic approach, optimal architecture and hyperparameters of the model were found and applied. Software tools and software libraries were chosen and justified. The design model was trained. The method to automate translation quality assessing was suggested. Translation module for corporate tool based on the neural network approach was developed.